Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be talking about solving equations by addition. First thing we need to know is what an equation is. It's a number sentence that contains an equal sign, and I add that the equal sign is somewhere in the middle. It's not an expression where we have an equal sign at the beginning like we did last time, where it says is equal to x plus 2 when x is equal to a number like 3, where we go through and then we say 3 plus 2, which gives us an answer of 5. We're not going to be solving it like that, which is an expression. We're going to have an equal sign in the middle somewhere. So we're going to have something like x subtract 8, so a variable, could have been any letter, I chose x, subtract 8 is equal to 12. When we want to do this, we're going to be solving equations by addition. We need to do the opposite thing to whatever's been tied to our variable. It's like undoing a knot. If you continue to do the same thing and same thing to the knot that's already been done to it, the knot just gets bigger and bigger. If you want to undo a knot, you have to do the opposite. You have to work backwards. So if you want to get rid of a subtracting 8, or we could think of it as a negative 8, we need to do the opposite to it. So we're going to add 8. I'll write it off to the side here so I can keep track of what I'm doing. I'm going to add 8 to both sides of my equation. So I need to go x subtract 8, and I need to add 8 is equal to the same as 12, adding 8. And it's really important to do it to both sides of the equation. Whatever I say I'm going to do to undo this, adding 8, the opposite, I need to do to both sides of the equation. Just like children playing a game on teeter-totter where they set and balance each other out, if one person moves, the other person has to move the same amount to keep things balanced. We need to keep our equation balanced. If we change one thing on one side, teeter-totter, or the center point here, the fulcrum, we need to balance it out on the other side by doing exactly the same. So if I have x, which could be any number, but if I take any number and subtract 8 from it, and then add 8 more, it's like those cancel themselves out. They go to 0. So all I'm left with on this side is x. On this side I have 12 plus 8, which is 20. So now I've solved my equation. I found that x is equal to 20. In this one I have a different variable, z subtract 2 is equal to 9. Well, I know I want to do the opposite, so I'm going to add 2 to both sides. So I'll write off to my margin that I'm going to add 2. So I have my variable subtract 2 plus 2 is equal to 9, and I have to make sure it's on there plus 2. I have a plus 2 on both sides. My equation is staying balanced. So I'm going to end up with z subtract 2 minus 2, which brings us to 0. Z is equal to 11. I could take that back into my original and check it and make sure it's right. So now I say z is equal to 11. 11 minus 2 is 9. 9 equals 9. Yeah, I got it right. These ones that we're starting with are very basic. Probably could have done that in my head to begin with. Could have thought to myself, something subtract 2 equals 9. Oh, it's going to be 11. We're trying to get the format and the way of thinking down right now. It's more important than actually just skipping to the answer. So this line is important. It's good practice for later when we get more complex equations. Things might be spun around as well. 14 is equal to y minus 7, but I'm going to handle it the same way. I'm still going to add 7 to both sides. So I have 14 plus 7 is equal to y subtract 7 plus 7. These still go to 0. So on this side I'm going to have y. On this side I'm going to have 21. 21 is equal to y. I can see 21 minus 7 is 14. Yeah, it's the same on both sides. I got that right. You'll notice I go through, I'm doing my best to keep equal signs as straight as possible down the center. I went a little bit crooked on that one, but these ones have stayed the same. It's important to point as well that my equal sign isn't going to jump all over the place. It's going to come down the center of the question. So this time we'll try to line it up and make sure we stay down the center. In this case I have negative 8 plus k is equal to 5. Alright, this is the same problem. I could rearrange this and say k subtract 8 is equal to 5. That would give me the same place. But adding 8 will get rid of it a little bit easier. So I have a negative 8 plus 8 plus my variable k is equal to 5 plus 8. Those still go to 0 and cancel out even though they were in the opposite order. And k we find out is equal to 13. So negative 8 plus 13 would get me to 5. Yeah, that balances out. We aren't stuck with integers anymore. We can use rational numbers. We may have not only negatives, but we may have decimal places or even fractions. But there's no difference with these. We're still going to do the opposite. So if I want to undo the knot of subtracting 3.5, I need to add 3.5. So I have z subtract 3.5 plus 3.5 is equal to 8 plus 3.5. Remembering to always do to both sides what I said I'm going to do, undo the not. So in this case, I end up with z is equal to 11.5. And I can put that back in the original and check to see if I had it right. 11.5 minus 3.5 puts me down to 8. All right, the last one, I'm going to add 6 to both sides. So I end up with x subtract 6 plus 6 is equal to negative 9 plus 6. These cancel out, so I'm left with x. X is equal to negative 3. So when solving by addition, we're going to do the opposite. Because we see a subtraction there, we're going to undo the not. Thanks for watching. Be sure to check the class website for the assignments, the lesson notes, and additional examples.